Hey everybody, CBQ here, back with another edition of How It Works, in which we dive into how the autonomous mowing system works on our mowers that we upfit to enable you to reduce the cost of labor for lawn maintenance. Today I want to talk about power and energy and what is consumed and produced on our mower with the upfitted technology. This is a Wright Standard ZK, our current generation model, and I'd like to talk more about power. So this model, this current spec generation, is running on the Kawasaki FX850V engine. That is the main component that's producing power while the system is going. You also have a battery. This is a Duralast Gold system. This is a 12-volt battery. On a standard stock mower, these two components are pretty stock. When we add the autonomous mowing capability, we've upfitted it at the factory to enable the autonomous mowing, and so we have additional power draw. First, let's talk about how much power we have in order to work with. So first thing we do is we upgrade the alternator on this mower. It's now a 20 amp alternator, so that is our budget. If we were to consume more than 20 amps for a sustained period of time, we're gonna be drawing down that battery, which is bad because we cannot crank. With that 20 amp budget, what do we have to work with? Well, there's two main components that are taking up some of that power in our system. During sustained usage, the electric controlled actuated hydro gear pumps are drawing about 11. That generally ranges in range. We'll do that as a max when we're going uphill or switching back and forth. And so that power draw we have to work with. So that is a given. When you talk about the extra Greenzie sensors, we have to talk about our components. The main one is the computer, and this is providing most of the power. This box on the side is the main system that's drawing power. Add to that the sensors, including the GPS, IMU, some of the lights, LEDs, and other components, including LiDAR in our newest generation, and we're at about 18 to 19, which is just under our budget. Now, so that means that when the system is running, even at max, we're gonna be just under that budget, so we're not gonna be drawing down that battery. Now, the ways you can get in trouble, if you'll notice, when I flip on the mower, our system does come on, so we're gonna be drawing some of that power. We're gonna be taking about, 8 amps when all's told. And while the system is booting, CPU's spinning up, system's coming on, all our sensors are calibrating. So now we're at about 8 amps. Now, if you were to let this sit for quite some time, you could draw down the battery. Now, luckily for you, most of the time you just instantly go to crank. And now once you're cranked, you have that full 20 amp coming off that alternator. Now, we are doing a draw here, and so what our system does, if you do switch it to the off position, we don't immediately switch off. We actually have a shutdown process that's waiting. Timer is going so that it will shut down in about, I think it's set to about 5 minutes. That enables us to squirt up any data we need from the most recent jobs or anything we've done. It's communicating back to our servers. So once 5 minutes is up, that does shut down. It does a quick shutdown, and now you're drawing very close to about zero with all systems off. So that is the power consumption on this unit. Our new P5 units are a little bit better. We've actually got a higher, bigger engine block on these. I'll be happy to go over those very, very soon. Those are in production now and out in the field. So that is running a new engine. That's the Vanguard 40 horsepower with a substantial alternator. We've upgraded the battery to a deeper cell, larger system to give us even more wiggle room in running an operation. So that's it for this week's How It Works video. Hey, let me know in the comments, what do you want to see? What's next? How do you want to know what systems, how they work? Drop a note, let us know. Thanks, everybody.